Hi again, this is Victor, your host at StudyLab, and today we're continuing the third part of our series on Bash scripting basics with a talk on the ins and outs of the test command. If you missed our previous video on AND lists and OR lists, you might want to check it out before proceeding because we'll be building on that in this lesson. Now let's go to the terminal and see what the test command is all about. Test is a command that evaluates an expression and returns an exit status of 0 or success if it is true, or an exit status of 1 or failure if the expression was false. Once we understand test, we'll be able to understand the workings of the if statement later on. So let's check out the help for the test command by typing help space test. So as you can see, it tells us that test evaluates a conditional expression and it either exits with a status of 0 or true or 1 or false, depending on the evaluation of that expression. Test can do file-related conditional checks, string-related conditional checks, number comparisons or arithmetic tests, or even tests related to shell options or shell variables. To get more complete and up-to-date information on the Bash built-in version of the test command, you should check out the Bash man page by typing man space bash. Next, you can search for conditional expressions and make sure you use uppercase letters because the search is case sensitive. Hit enter, and here you'll get more up-to-date about the options that the test command accepts. So now let's play with some examples. We'll use what we learned in the previous video to echo different messages on the screen depending on the result of the test command. So let's start with some basic file tests. If we ls, you can see that I have a list of directories in here. So let's start by doing some directory tests. If I type test space -d for directory space, and now I type the name of one of my directories, videos, this will basically test if videos exists and it is a directory. So if that is true, I want to echo true, or if that test is false, then I want to echo false. Pretty simple. If I hit enter, you can see it says true. Now, if I type in a non-existing directory, it will say false because that's not a directory. So let's quickly do some other tests here related to files or directories. One other frequent test is the -e, which basically checks if there is either a file or a folder with that name. So it can be either a file or a folder. In this case it says true. Now if I create a new file by using the touch command to create an empty file, touch my file, hit enter, and let's go back to our command and test against this file, my file. Hit enter, and you can see that it also says true. We used it before with a directory, and now we used it with a file, and this just basically checks if the file or folder exists. One other test is -s for size, which checks if the size of the file is greater than 0, basically. So if the file is non-empty. If I hit enter, it says false because touch creates an empty file. If I go into Vim and edit my file and add some content, save it, and then run the same test, it will return true because now the file has a non-zero size. Let's clear this up and run 3 other useful file tests. -r for readable checks if the file has read permissions. True. -w for writable checks if the file has write permissions. It does. And last but not least, -x checks if the file is executable or not. False. If I make it executable by running chmod +x my file and then run the same test, it will say true. So those are the most useful file and directory tests that you can use. There are many more options, so I suggest you go through the bash manual page and check out the other options. But for the basics, that's pretty much it. Let's remove our file, clear this up, and now let's see how to do arithmetic tests. Okay. Let's test if the number 3 is equal with -eq is equal to 2. That's false, obviously. So before we continue, by looking once again at our file tests, you can see that we have an operand here, -x, an operator -x, and one single operand, my file. These are called unary conditions or conditional checks. Now, when we're dealing with arithmetic tests, we are doing binary conditional checks, meaning we have 2 operands here. We compare 2 things instead of just doing checks on one thing, like we did with checking the existence of one file. You also have 2 useful binary file checks, which I forgot to talk about, so let's go back first and do that. Let's create 2 files here. Call the first one old file, and after we've created this, we create a new file. So we now have 2 files. This one was created first and this one was created afterwards, so it's a newer file. And now we can check if our old file is older than with -ot, then new file. Hit enter, it says true. If I do this the other way around and check if new file is older than the old file, it says false. And finally, there's also an -nt option, which checks if a file is newer than another file. And if we hit enter, it says yes, new file is newer than old file. Okay, so that's it with the file checks for real now. Let's just clean this up a bit, clear, and then continue with our arithmetic tests. So we first ran an EQ test to test if two numbers are equal, and it said false because 3 isn't equal to 2. Now the opposite of that is to check if two numbers are not equal with -NE. If we hit enter, it says true. 3 is not equal to 2. So what next? We can check if the first number is less than LT, the second number, false. We can check if it's less than or equal to the second number with LE, false. We can check if the first number is greater than the second number, GT, true, or greater than or equal to the second number with -GE, true. And that's pretty much it for arithmetic tests. Pretty simple. Let's clear this up. And finally, let's do a few string comparisons. First, a couple of unary tests. Test-n, and now we have to write a string. It's usually a good idea to enclose it in double quotes in case we have multiple words, but if you just have a word, you can also type the word like that without quotes. But for the most part, it's a better idea to always use either double quotes or single quotes. So the -n option checks if a string of characters has a non-zero length, basically. So if it's not empty. So if we leave it as an empty string, it will say false because it's empty. If we type in some characters in here, it will say true because it's not empty. The opposite of that is the -z option, which will return true only if the string is empty. So now it will say false. And finally, let's move on to the binary string tests and check if string 1 is equal to string 2. And it says false. Next, if string 1 is not equal to string 2, so exclamation mark equal or bang equal, it says true because the strings are not equal. And now for the interesting part. If you try doing this to check if the first string is less than the second string, lexicographically speaking, or alphabetically speaking, you'll get an error. No such file or directory, which is really weird, but it's really not, because what happens is Bash thinks that this is a redirection operator, so it interprets all this as a file name instead of a comparison. And the same thing happens with greater than for strings. actually with greater than, it does return a value, because it just tests against this expression, and since it's not empty, it evaluates as true. But what it does is, if you ls here, it creates a file, because it thought that this operator is supposed to redirect the output of this command. So let's clean that up, string 2, and let's see what we can do about these strange errors. It's simple. You basically just need to escape this character using a backslash whenever you use the test command. Hit enter, and now it's correct. It says that string 1 is not greater than string 2. If we use the less than operator, it will say true, because yes, string 1 is less than string 2, because 1 is less than 2 in the lexicographic order. Okay, so I think that's pretty much it for the basics of the test command. And for today, let's finally see what the bracket command is all about. If we run help bracket, you can see that it does pretty much the same thing as test. It evaluates a conditional expression, and it's an actual synonym for the test command. So our last command above could also be written as bracket space and then this comparison and close bracket, enter, and this is the same thing as this, but always remember to close the brackets here and remember to add the spaces after the opening bracket and before the closing bracket, otherwise it will error out. So let's try that. If we remove the space, we'll get an error, or same thing if we remove the space here, another error. Why does that happen? It's a little, I don't know, Bash looks like the greatest grammar Nazi ever. In normal programming languages, this usually doesn't happen. So if you're using C and declare a variable, for instance, you can type string var equals test, but you can also do it as string var equals and remove the space test, or string var equals then double space test, and all of those will work, but not with Bash. The secret here is to just treat bracket like it were any other command, and then it will all make sense. Because if you don't type a space after cd, for instance, and your directory name, for instance, I want to cd into videos, then the shell will have no idea what you're trying to say. It will interpret all this as one single command, and it doesn't know what cd videos means. Cd videos, command not found. So only when you add the space, Bash can properly parse these words, and it will know that, hey, cd is a command, and what follows as the next word is an argument to that command. with bracket, it's the exact same thing. If you do bracket string 1 is less than string 2 without any spaces, Bash will have absolutely no idea what you're trying to do there. So you have to separate things out for it. Bracket is one word, then the next operand must be followed by space. This operator must be followed by space, and this operator must be followed as well by space. And if you do that, everything's fine. Bash needs space, so don't smother it, I guess, is the conclusion. That's it for today. I hope you enjoyed this video and found it useful. Don't forget to subscribe and hit the bell so you don't miss out on the next videos I'm about to post. Until next time, have fun and keep learning.